All right. So everyone, uh, welcome to Get Started. This is the first in a series of planned uh, presentations from the University of Redlands chapter of the Google DSC. My name is Anuj Patel. I am the project manager for this chapter. And so let's go ahead and get started. This format is a bit different. We're not expecting a huge turnout, so we're giving everyone the option if they have a mic, if they want to turn it on and ask a question, then feel free to. If you don't feel comfortable or you don't have a mic, feel free to post any questions you have in chat. We do have people looking that can answer your questions or uh, tell me so that I can go ahead and address it in a visual manner. So first things first, we're going to have to set some things up. This is going to be creating an account and installing some software. And the first thing we're going to do is set up an account on the site called GitHub. GitHub uh, actually provides students a lot of free stuff, like an absurd amount of free stuff. So there's this link. If you have the Google Doc open, it should be there. It says education.github.com/students. If for some reason you're here and you're not a student, that's perfectly fine. You can just go ahead and make an account on github.com. You probably want to make this account with your own personal email first, because this is probably an account you're going to always want to have access to. But then to get the GitHub student perk, you can always just go into your settings and under emails, you can always just add your student email as a secondary email. And that will allow you to grab those GitHub perks while also keeping your primary email associated with the account. So while you, that will be used later on, and go ahead and take your time doing that. There's no rush on this one. But next, we're going to install something known as Git. Git is obviously what we're all here for, and it's pretty easy to install if you're on a Mac. If you just go ahead and open the terminal, and we're just going to run this command, brew install git. If you do have the Google Doc open, it's not there. Well, I'll type it in. So it's just going to be brew install git, and you just go ahead and run this command in the terminal, and it will allow you to, it will just install git for you. But if you're on Windows, which most people probably are, including me, you have to go to this website, git-scm.com, which I know is in the doc, and you just go ahead and paste that in, and you're going to get a window, a website that looks something like this. And you're just going to go ahead and click this download button right here, and it will go ahead and download, and you just have to install with the defaults. So just run all the defaults. There's nothing else that you have to take care of. So while you're doing that, just to give you a chance to get that done, and any questions that come up while you're doing that, go ahead and do that, and I'll just talk in the background about what Git is. So Git is one of many systems that are called VCS, or version control systems. These are tools that basically allow people to take snapshots of their projects at certain periods of time. So these snapshots are basically full working versions. And then if you want to continue working on it and you're worried that you might break something, you always have that old snapshot to go back to. So it's almost like a really powerful undo button, but it allows you to take multiple of these. And so it makes it really easy to navigate, especially with large like code bases and projects. And so in Git, these snapshots are actually called commits, and this is the terminology we'll be using. So when I say we're making a commit, we're basically taking an image of the entire project and saving it into some space where it won't be touched again. So Git is, of course, primarily used by software developers, but it's not necessarily just to be used by them. So you'll actually see in this presentation, besides running the Git commands, I won't be writing any code. I'll just be typing out a story. In case you were wondering just who thought of making it, Linus Torvalds, the creator of Linux, that crazy guy, did think about making it. Uh, he's obviously super smart, and so some Git commands can take a little bit of time for most people to get to terms with, especially with how powerful they can be and with the huge amount of uses that they can come with. So let's see, what are other VCSs outside of Git? They're they're not really that many that are actually used. I don't actually know any of the others off the top of my head. They're mainly used in older legacy systems, or they're customized in some way, I think. Most projects nowadays tend to use Git. Um, yeah, the name is escaping me. It began with an S, but uh, there are others. Git was actually made in reaction to one of them, and if you ever look up a Linus Torvalds talk about Git, um, he does not have kind words for that other system. Um, Git is currently the norm. It uh, is the most popular because it works well with Linux, and uh, GitHub, that account that we were setting up, is owned by Microsoft now. And so with Linux and Microsoft both being present on uh, in the Git environment, it kind of is natural that people gravitate to that more easily. So as Raf said, there's one called shareware, and yeah, so um, here is actually a simple picture of a Git repository. So this is a very simple Git repository. Uh, if you get into bigger projects, they'll probably be way more complicated to actually map out image-wise. But each of these circles represents commit, one of those snapshots we were talking about of the code base. And so we have this initial commit, right, which is basically the very first picture of the code base. And then every future commit is basically a new version, right? An increase in the version number. And then you have what's called a branch, where you can test something without affecting the main project. And if it doesn't work, that's fine. You can just abandon it. And this, so as you can see, this is called a feature branch. And then we come to the most current commit. So on the main branch is called the master branch, and the most current commit is going to be right here. And generally, that's where we're going to be looking. And so you see this term head. Head is where the user is looking. So generally, it's always going to be at the end, unless you have some reason to go backwards. So that's a basic Git repository. If you have any questions, please feel free to ask. Um, so now, if everyone has Git installed, I think we'll go forward and start with working actually in Git. What could be some reasons to go backwards? So say there's some functionality that was depreciated. Like say for some reason you took out a feature going forward and you want to go back to reference it for some reason, you could go back there. Say for some reason there was like a critical bug in your latest commit that just was not caught for some reason, you could always roll back for that reason. Um, or you could just go back to test out another way to implement what the most current feature was. So there are multiple reasons you could uh, want to go back and look at old code. You could also just want to like actually compare. There are much easier ways to compare your current state and your old state, but those are two things you could do. So if everyone's ready, we're actually just going to go ahead and get started with Git. So if you're on a Mac, you're going to go ahead and open the terminal. And if you're on um, Windows, you're going to open Git Bash. So Git Bash, I will show you right now. Uh, so Git Bash is going to look something like this. I do have some styling on it, but if you search your computer for Git Bash after installing Git, this is what you're going to get. Now, on Windows, normally you would have the command line, uh, but command line uses different prompts. You could probably do this in PowerShell, but I do like Git Bash's just styling options and stuff. So that's where we're going to be doing it. Um, so uh, for Git, one of the first things we're going to have to do is there's two commands you have to run the first time you install Git on a system. You only have to do these once, and they are going to be git config global. So those were two dashes and then global. So that's what's called a flag. In this case, global being it's going to apply to the entire computer, not just where I am in my computer's file directory. And then user dot name. If you're familiar with any object-oriented language, this is the user class, the name element, and we're going to set it. So in this case, I'm going to put my name, and then I'm going to hit enter. And then nothing's going to happen. But it just, uh, so as you can see, if you were to type in a git command that does not make sense, Git does give you uh, notes on like what you can do. So in this case, it's telling you to say git dash dash help, and it will explain everything. Uh, not everything, but a lot of things you can do in Git. So dash dash help will show you a bunch of stuff. So we're not going to go through that now. I'm going to continue just writing those commands. And that's how you set it. Now, if you saw, I did make that mistake earlier, and the actual proper command is git config user.made, and that will show you what you've entered. And if you were to do that for email, it would also show you that. So that's how you can check that. So these you only have to do once, and the reason you're doing them is so that whenever you do something in Git, you make a commit or anything else, it's going to track who did it. And so this is your way of keeping accountability on what's going on in a project. So in the case of a single person project, not so much a huge deal, but if you're doing project with, you know, even say 2 or 3 individuals, keeping track of who did what just kind of allows you to go up to someone and ask what certain things mean if it's not like making sense, or how they plan on implementing future features with what they did, things like that. So, uh, are there any questions? Yes, all these commands should work on Macs. Dash dash is for flags. So flags are certain like modifiers to directives. So like we saw, global makes it so that it applies to the entire computer instead of, say, just where you are. There are a bunch of other ones. We not get into really many of them at all because they can go quite deep, and they are more for higher level use once you're comfortable with the basics of the commands. So then for our next thing is we're actually going to change directory. So CD is change directory. It allows you to navigate through your computer. And I'm going to go to my desktop. And then from my desktop, I'm going to make a new directory. So make dir. And the name of the directory will just be Git presentation. And then I am actually going to change directory into that thing I just made. So thing with command line and terminal things is if you type enough characters for the computer to figure it out, you can just hit the tab key and it will auto-complete it for you. And then you can go ahead and just change it to that. So now, just to show you, this is...
I'm sorry to stop you. We have a question in the chat. Do you prefer the terminal for Git commits or some other process?
Okay, so Git commits, it depends. Generally, if you are lots of IDEs nowadays do have the ability to do Git stuff for you, but you'll also find a lot of places, not a lot of places, but a lot of your coworkers when you go work will probably be a bit older. They'll probably be a bit more adept with using the command line, and so they'll do it there. The command line does offer some added flexibility in that you can do just a lot in the command line along with doing Git stuff. So, like, say you want to make a new file, you can make a new file really quickly. You can just go somewhere else and look at something else very quickly. So fluency with the command line is not a bad option, and having the option to do both is always good. This it also just gives you more ideas about how Git is actually thought of, and so you can have uh, more knowledge about what different options in your IDE do because you'll be playing around with all of the possible options here.
Just to chime in, I'm going to plug. We have actually a follow-up to this. That's going to be using software called Git Kraken. It's a drag and drop software for a lot of the similar processes. So it's very important to understand how these underlying processes work and the commands associated with them. However, we will be teaching software that's a little bit more intuitive and user-friendly. So if you are interested, tune into episode.
Yes. So here I'm going to run this ls-a command just to show you something. So ls is just going to show all files and directories in my current position. Obviously, it should be empty because I just created it. And then -a is actually going to show hidden files. So you're not going to see anything right now, obviously, but we're actually about to run our first git command, and I'll show, and this will show you what happens after you run that git command. So first git command we're ever going to run is git commit. Oh no, wow, I got ahead of myself. Git init. So Init is short for initialize, right? So it's the start of a project. Uh, you can run this in an empty directory. You can run this in a directory that has files in it. Doesn't really matter because Git is just going to set up a fresh repository with nothing in the repository. So if you run this, see initialize empty Git repository in this place. And now if I run ls-a again, you're going to see this .git. So if you're not familiar, any file or folder that begins with a dot is termed a hidden file. So unless you have it explicitly stated to show hidden files and folders, it's not going to show when you open File Explorer or Finder or whatever it is on a Mac. So I'm going to go ahead and clear this up just so that we have some room. And then I'm going to run this touch command. Touch is has a lot of uses, but one of the simplest ones is just to make a file. So you just type touch and then you type the file name and it will make an empty version of that file. So here I'm just gonna write you guys a story. So story.txt is what I'm going to touch. And that's just made an empty file called story.txt for me. And with that done, we're gonna go ahead and open that story.txt. So I'm just gonna type notepad, story.txt. If you don't want to use notepad, sorry, hold on. Oh, so we do have people that are joining. So let me just reshare this link very quickly. So if you just joined, here's a link that contains all the commands and website links that we're using. And so back to this. So just if I hit, so Notepad is what I want to open story.txt in. You can open it in a variety of other things. If you have like the Atom text editor installed, instead of Notepad, you type Atom. If you have Visual Studio Code installed, you can just write code instead of Notepad and it'll open it in there. So I'm just going to type that. And then I am going to so ta-da, fancy empty notepad. So we're just going to write a basic thing. So this is a story, right?
Anush, sorry to cut you off, but for Macs, we have something called text edit. If you guys are using a Mac, you can open it there. I don't think we have Notepad.
Oh yeah, that does make sense. Sorry about that. Yes. So if you're on a Mac, text edit and then story.txt or whatever you called it. You could go ahead and just make it a Java file if you want, right? Story.java. Who cares? So you can go ahead and so I save this and I'm going to close it. So now we have our story started. I'm going to come back here. And so just to go over what we've done, we've run these commands to identify ourselves in Git. We started our first project. So by running Git init, we just made it so Git knows that this is a project directory that is going to have version control. And then after making a story project, our story, we can do these two commands. Okay, so these are git status and git add with a period. So let me. So just to show you, git status It shows you the status of your repository. Okay. So it shows you what branch you're on, master. If you remember from that diagram, master is the main branch, right? It is the main thread of your program, and every Git project is going to have a master branch. And then, so no commits yet. So we have no snapshots of our project saved. So Git's not really helping us right now, right? It's just empty and it doesn't have any information for us to reference. And then it has this untracked files. So untracked files means that Git doesn't have any record of this file existing at all in any of its snapshots. Makes sense in this case because there are no snapshots. But even if, say, we had a project, if we were to create a new file, then that new file would show up here in untracked files. And then nothing added to commit, but untracked files present is Git's way of telling you, hey, even if you try and commit something, nothing's going to happen. You have to stage it. You have to tell me what files you want to add before you commit something. So this is where this command comes in, git add dot. So git, the general command that says, I want to do something with the version control software. Add means that I want to get stuff ready to be committed. Basically, it allows Git to do some preparation work behind the scenes and take a preliminary snapshot and get everything ready. And then dot just means everything. I want you to look at everything, and Git will look at all the files in the project, and anything that's changed, it will get ready to commit. If you didn't want to do that, if you only want to touch a single file or any number of files, you just have to name them. So in case I would go story.txt. In this case, since we're working on a simple project, a dot is much faster to type. So we'll do that. And then nothing happens. Well, something did happen, but Git doesn't feel the need to tell us because it was successful. So let me clear this up so that we can get a screen to look at. And then we're going to run this git status command again, and you'll see what changed. See, we no longer have story.txt under untracked files. It's now been tracked, and it's ready to be committed. So still no commits. We haven't given Git any snapshots to take, so there's nothing saved in Git yet. But we've told Git, hey, get ready, I want to save this. Now, the way to, we're actually going to go ahead and do a save operation. So in this case, we're actually going to go ahead and say git commit, and it doesn't care. There's no way to specify specific changes. It's just everything that you staged to be committed with the add command is going to be committed. And now when you hit enter, it's going to open the text editor involved, associated with Git, and it's going to ask you for a commit message. So I'm going to hit this, and then you see waiting for your editor to close file, and then update hashtag set state idle. Okay, so now what you didn't see because of the way this works is that Git actually force opened this Visual Studio Code. So I have it associated with Visual Studio Code, so that's what it's going to enter open for me. And here is where I'm going to write my commit message. So commit messages are something where you want to be a little bit verbose about what you did. So here, your first line is generally something you want to be a bit, what's the word? You want it to be a bit succinct. You want it to basically encapsulate the entire thing in this entire change in as short way as possible, because that's what people will see as a little snippet whenever they just look at the overarching change. And then down below, you can be a little bit more elaborate about what you actually did. And then if I were to save this and then close it, you will see a change in this. You see, we were last up here in this update set state idle, and then it checked for updates, it downloaded, and then you see this first line, that snippet that I told you about, get stated right there. And then it tells you what happened. So one file change and one insertion. And Git status now looks like this. It's clean, right? It says on master branch, nothing to commit, working tree clean. So that shows that there's no changes since our last commit. Git is, we are up to date, or Git is up to date with us. So we haven't done any more work since our last commit. Now, if emojis to commit messages, there are ways to do that. It's a standard that some places do just to make it more verbose for what you're doing, basically. So in your commit message, you can put commit messages with emojis that kind of encapsulate exactly what you're doing. I'll have someone try and find the link for that. I don't remember it, but I'll show that to you in a bit. Now, one thing we can do is actually run the command git log. So what git log does is actually shows you a history of your commits. So it's very useful in looking through all your commits and just seeing where you want to go or where you are. So here's the commit. This, if you're familiar with like hash maps and stuff, that's a hash code. So it's a unique identifier for this commit. And if you look here, it says head is pointing at master. So head, if you remember from earlier, head is the term for what
Gabi, there's
what
no
we're
there's no stupid questions, by the way. So Gabi asked, can one do comments in the terminal?
Yeah, sure. I'll actually cover that with my next commit. So good, nice question, Gavi. Hold on. You can do it. I assume this is for commit comments. You can do it. It's not recommended because you can't be as verbose, or like you can't be as neatly verbose with it, but you can do it. So I'll go ahead and get that done with
The other thing to note is that when you, in fact, open a commit message, Git leaves comments for you. So you can see how comments are done. I think it left it for you in the VS Code as well.
Oh, okay. Yeah. So there we can see our first commit. And now we're going to actually make another change to our story, right? So I'm going to go ahead and open this back up. And actually, I'm not even going to show you guys. what I did, because I will show you how you can see that later. I'm going to make that change and I'm going to save it. So now you can see that I've closed the notepad document, and now I'm going to show you this command. This is insanely powerful command, and it shows you a lot. It's called git diff. So git, and then you can think of it as difference, right? And when you run it without any other arguments, it shows you the difference between your last commit and any changes you've done. Can get really overwhelming, so you may want to put arguments and flags and stuff afterwards once you get more familiar with that. But it's going to show you the difference between one story.txt and the other. So from the commit and from my change, right? So uh, here it says this red is what was initially there, and then this green is what's in there now. So it also shows you that there's no new line at the end of the file. So I never hit enter at the end of the line. And this is like a rough estimate of like -1 line plus 1 line kind of thing. So it sees it as me having removed this entire line and added this instead. So now, if you remember git status, this will now show us the last, one of the last variations for this thing, for this presentation. So here, so we're on branch master and we have changes not staged for commit. So remember, initially it said it didn't have this. Instead, it had untracked files and showed a story.txt. That was because story.txt didn't exist in the repository's history. But now story.txt does exist. Git has a history of story.txt. It knows what story.txt used to look like. And so instead it just says, there have been changes in story.txt, and you haven't told me that you want to ready those changes to commit. And so it's just going to show you that. And then obviously, as I said, I haven't added it. So I'm going to go ahead and git add dot like we did before. I'm going to stage it for commit. And now, answering Gabi's question, we're going to git commit, and then we're going to hit this -m flag. So message, you can think of it like that. And then I'm going to put made for it amazing. I don't know, inflating 0. So you can do that, and then you go ahead and hit, and then you can see that this commit went through. That was the commit message. The file changed, the insertion, and the deletion. Now you can see that that M flag allows for really quick messages, but it's not great to type a lot of text well formatted in the command line. So generally, if you were working on your own repository, that's something you could definitely do. But if you were working with a repository that has certain standards, you would have to make sure that you could meet those standards with the command line commit. And so we're actually going to go ahead and run git log again. Let me go ahead and clear this mess up and run git log. And here are our 2 commits. So Now, as we talked about looking back at the past, look, say I had regret about inflating my ego, and I was like, what was I thinking? I could actually go back and look at this story by saying it and look at how the story was beforehand by going git checkout, and then here, this is where these hashes come in. So hashes are, remember, if you're familiar with hash maps, hashes are unique identifiers. Obviously, no one wants to type out this giant hash. So Git makes it easy in that you just have to type out the first 4 characters of the hash as long as they are unique. So in this case, I'm going to type 84BA. Yours will be different, of course. So you'd have to look at your own because Git does this by itself. And Git's going to go ahead and give me this whole spiel. So here's one great thing about Git is that as complicated as it can be, it does give you a lot of messages about what's going on, about things you can do after that command you've ran. So here, now I've switched back, right? I've gone back in time. I've gone back to the first snapshot we ever typed. So if I uh, were to actually open the story, and here, I'll show you guys this story. You can see this is back to what it was initially. So that's a way to look at past work. And then if I wanted to actually go back, I would go git check out and then master. So master is the main branch and the most recent commit. And so now we're back with the commit where, if you remember the message, I inflated my ego. So if I actually show you that, you'll see how different it looks. Not very different. I didn't have much time. Forgive me. I'm not the greatest writer. So that was what I committed when I didn't show it to you guys. And so that's the power of Git in a snapshot, in like a nutshell. Ooh, I totally butchered that idiom. So that's why people use Git. Now, Git checkout, the command we just ran, it's actually one of those really powerful things that has a lot of uses because people want to do a lot of things with the same command. So here are only actually 3 of them. You can actually probably do a lot more with it, but these are some common ones. So if I were to change the file and then I were to do git checkout and then dash dash and then the name of the file I changed, it reverts it back to its last commit state. So I would lose that work that I did. But say I want to undo it, go back to the most current commit, then that would allow it to do it. And then this was what we just did, the 4-character unique hash. And then there's this one. This one gets a little bit complicated and it doesn't lend itself to us doing it in the command line. There are a few resources I'll recommend that are visual representations of this, and that's a bit easier to digest. And so it's head tilde and then the number of commits back from where we are. So remember, we are at head, and then tilde is almost instead of minus, and then some number of commits back. So that's how you would do that. And so now we get to actually the meat and potatoes of what most students use Git for, and that's building their portfolio on GitHub. So if everyone has GitHub set up and Git, then you can do this. So what we're going to do, is create an empty repository on GitHub. I'll create an empty repository on GitHub, and then I will show you how we can push what we have on our local machine up onto GitHub. So here is my profile. And so I'm going to go ahead over to my repositories and create a new one. I'm going to call this Git presentation. And don't descriptions are nice. Generally, you do want to be verbose about what's going on. It helps people who have no idea what's going on get an idea. In this case, I'm not really hoping to present this as any work of mine. So in general, if you want, recruiters, employers to see your work, you would set it to public. I'm not exactly proud of this story, so I'm going to go ahead and choose private. And then I'm not going to click any of these. These are very useful things. I will go over Git ignore, readmes or descriptions of your projects, and there's a lot of formatting that should go into readmes that you can read about, but they're simply just text files that explain your project, and that formatting just helps people read readmes in a standardized way. So we're just going to go ahead and create this repository. And there we go. It was that simple. So here you see this empty repository, but GitHub does some really nice things for us. It gives us some quick setup stuff, how to do some stuff on the command line, or how to push from an existing command line. And actually, they're kind of stealing my thunder here because they're showing you how to do it with an existing repository. But in this case, we're going to go ahead and up here where it gives us this URL, and we're going to go ahead and click the clipboard thing, clipboard icon, which will copy it for us to paste later. And then we're actually going to go back to the command line once more. And here, we're actually going to run this command. So git remote add, then I'm going to call it origin. This is it's a standard practice almost. And then we're going to go ahead and just paste that URL I copied. So let's go ahead and break this down. So remote, this is the whole point. It's basically saying I want Git to I want to edit this remote parameter in Git. So remote is a remote repository. So it's a repository that's not stored on a local machine. It can be stored on another machine. So say I had someone's access to a server somewhere. So say my company really wanted to keep stuff for private, then I could have access to the server's IP address or something. But in most cases, it's GitHub. That's standard. That's what we'll all be probably working with for the foreseeable future. And then we're saying I want to add a remote location, and then this origin is a nickname. It's the nickname for the location, because otherwise we'd always have to type out this URL, and obviously no one wants to do that. And so origin is the standard nickname for basically the main repository, right? From all things all changes go to the origin, and everything new comes back every time you want to clone a project, you'll go to the origin. So when you run this, it does it. So Git.
Yeah, there's a couple of questions in the chat, if you don't mind.
Oh, sorry. So can you put multiple repositories into one file on GitHub? You can do that. Generally, it's probably not good practice. Like I do it for like a class, just to keep everything like squared away. But it's not good practice. Because most class projects and stuff are like very different. Unless they're like in my circumstance, they're really small, so they don't really have much iteration going on with them. I don't really want anyone contributing to them. They're just there to show that I did the work. So that's why you do it. But in most cases, you do want each project to be in a separate repository so it can be iterated on independently.
Just to clarify, you can't actually have multiple repositories in one GitHub hosted repository. So on GitHub, you can only match a specific repository that exists on your computer. You can't have multiple repositories on your computer.
Yeah.
There's only one GitHub repository.
Yes, sorry, I did misread that. I for some reason read projects. You can have multiple projects in a repository, but one repository for those projects. So yeah. So why do you need a README? So READMEs are really important for other people coming in and looking at your project. READMEs are really where you, in plain English, spell out the point of your project, what's going on with your project, how other people could contribute to your project, what plans you have for your project, and issues with your project. They all come from the README in plain English, so people don't have to go into your code to get an idea of what's going on. They can go into your code ready to start looking for specific things. So README is like a norm in companies. So in the open source community, there may be a standardized way of doing READMEs, but then in companies, I think they generally have style guides, and I would assume that the README also has a style guide associated with it, just to keep everything standardized in the company. So from there, we will go back to this. Just let me just make sure I'm sharing the right thing. So, so we've set up this remote pointer basically to our GitHub repository. But now our GitHub repository is still empty, right? It doesn't have anything in it because we haven't put anything there. So what we're going to do is we're going to bundle this entire thing that we have, this entire, well, in this case, it's only a story, but we're going to bundle that and push it to the repository. So that way we do that is git push and push and then origin. So origin, once again, is this nickname we gave the remote repository. So saying origin allows us to not have to type out this entire thing up here. And then master. So master is the name of the branch we are on, right? So we don't have any other branches. That's for later presentations. But so this is only a single branch, and this main branch, the branch that gets named when you initialize your GitHub is when you initialize your Git repository is called master. So that's why we're pushing our master branch to the origin repository. So when we run this, it's going to go ahead and just tell us everything that's being done. And then says, here you can see it says to GitHub, new branch, master to master. And so if I were to actually go back to GitHub, so you see that this is where we left off on the GitHub repository. But if I were to refresh, you would see that it changed. It's got this story.txt. It's got my comment, my commit message, and it's got the commit history. You see there have been 2 commits in this history. And if you notice, it doesn't count me pushing to GitHub as a commit. It's not a commit, right? I'm just pushing the history of what I've done to GitHub. I haven't changed anything. I've just put it there. So it's been 16 minutes since our last change was made. And if we were actually to click this, where you could see all the commits I've done, the hashes, if you notice, they're still the same. There's a clipboard and there's stuff like that. And if you look, there's these 3 dots, and that shows the rest of my commit message. So now we get to a little bit of the open source nature of GitHub, right? So when you think GitHub, the main idea of GitHub is open source, people sharing projects, people collaborating on projects. Collaboration is beyond the scope of this series, of this presentation, but I want to show you how you could see an interesting project and grab it for you to play with, right? So here we're going to actually back out, and I'm going to actually go over to, so if you don't know who Raf is the DSC lead of the University of Redlands chapter, and he has this repository for our website. It's private, so you probably won't be able to see it. I can see it because he let me. And I'm going to go ahead and go over to this button, and I'm going to click fork. So you can do this with any repository that you can see that's interesting to you. Be careful. You probably don't want to do it with a huge repository, because huge repositories are probably beyond one person unless they're very experienced to go ahead and fork. As you can see, this has quite a few files in it, but it's not anywhere close to being as big as some other ones. So I'm going to go ahead and fork it. So I'm going to fork it to myself. You shouldn't see this. I'm associated with the DSC thing, that's why. But you'll get this. So it says forking. And so now if you see, I'm back in my repository, but I have this website all of a sudden. And so I now have this to play around with on my own. So any changes I make here are not actually going to touch Raf's repository. This is my playground, basically. And so if, say, I didn't like working up here and I wanted to work back down in on my computer, I could go ahead and, so I'm going to go ahead and back out of this Git repository. I go back to my desktop, and I'm going to make, I'm going to say a directory called DSC website. And then I'm going to go ahead and change directory into that DS.
Yeah, which we can't see your.
Shoot. Thank you. All right. So what I did was dot dot makes you back out one directory. So so I was at desktop Git presentation. By running dot dot, I ended up back in the desktop. So it backed me out one. And then I ran make directory, and then I created this folder called DS website. And so now I'm going to go ahead and go into DS website. So I'm going to change directory into DS website. And so now this is a new directory with no GitHub repository present in it. And that's good because, as we established earlier, you can't have 2 Git repositories in the same place and stuff like that. So what I'm going to do is go back here, and up here in this code button, I'm going to click the arrow for the dropdown, and you can see it once again. Similar to when we created our empty repository, we have this URL, and I can just copy that again.
Also to note, I have multiple branches in this repository. So when you are cloning, you're cloning all of the branches.
Right.
It's the master branch.
So if you can see here, once again, this is for the next presentation, but there are 2 branches here that we will be pulling down. But so I went ahead and I copied that, and then I'm going to go ahead and run the command. It's a really simple command. It's actually, in this case, it's actually something like you could call it a compound command, git clone. And what it does is it actually, behind the scenes, it's running actually multiple things. So it's running git init, it's running git remote add, and it's doing something, and then it's pulling down whatever is in at this URL. Oops. Oh, I fat fingered that. Sorry. So I'm gonna go ahead and receive all those objects. Now this is taking a little bit of time because this is a bigger repository, and it's just gonna pull all those down. So what's the difference between fork and clone? So fork is only for GitHub, really. No.
This one, if you don't mind, Anish.
Yeah, go ahead.
So when you fork a repository, it copies the entire repository from one account onto your account. So whatever exists on the initial repository, it will mirror that onto your account, and it is only mirrored at that point in time. The original repository moves upwards, you have to do additional stuff to pull back to where the original repository is. However, the changes that you make will not affect the original repository unless you specifically ask that to happen. That is known as a merge. A little bit different to cloning, where cloning is specifically taking the code on GitHub from something that you have access to and putting it onto your computer. So forking is from someone else's to yours. Cloning is from your own to your computer.
Oh, yes. Okay. Yeah. Thanks for handling that, Raph. So as you can see, it's finished cloning down our GitHub repository, and so we're not going to be doing anything with this. I just wanted to show you that it made this. It just makes its own folder, right? So it contains everything in a folder, and then I can just go into that folder, and you can see all of these files. And so that's just one way to get into seeing other projects and working with code that maybe is not your own entirely. And so we're coming to the end here, and we're just getting basically git ignore files. So git ignore files are a hidden file, right? So you see dot git ignore, and these files basically tell git commit and git stage and all of those to ignore certain file types that you don't want committed. Uh, so this is very useful in case you're compiling program because compilers tend to make a lot of intermediary files, like binary files and object files and stuff like that. And so you can just tell Git what to ignore in this file. So it does take a lot of thought on what you want to ignore, but luckily the actual team at GitHub have made a repository just full of Git ignore files that you can go ahead and copy down based on what language you're using. So actually, I'm actually going to go here. Oh, I did not copy that. So I'm going to go ahead, go here, and you'll see that all of these are Git ignore files for all the different languages. So you have a C++ Git ignore file. Redlands people will probably be pretty familiar with Java. So you do get a Java Git ignore file, and it will basically tells Git to ignore any jar files and all of this that gets created when you run the Java compiler. And so we're coming to the end here. As a closing, I just want to go ahead and give you guys some useful links. These links are useful to dive deeper into Git. So this first one, git-scm.com/book, is basically Git's version of documentation, and it allows you can go through and look at it. It reads pretty well for what's basically an ebook, and it has chapters and everything. And then you have learngitbranching.js.org, and this is a website that actually, through graphical representation in a game-like method, shows you how Git branching works, how to navigate. It lets you run some commands in the window so that you can see how it would affect a Git repository with images. It's very useful. And then we have this GitHub from the user Mungel that has a list of awesome open source projects that are looking for first-time contributors. So this is really useful if you want to look into getting into open source projects but are a bit wary of getting into a project and you don't know what to look for. This is a great list. It's organized by language. And then I've thrown a lot of commands at you, and some of them, you might want to explore more. And there's this great website called explainshell.com where you can just type the command into their little text box and it will break it down for you and explain what every part is doing. It's a very useful tool if you don't want to wade through documentation trying to find some specific thing. All right, and that's it. Just want to say thank you for coming to this talk, and I hope to see you guys in our next presentation.
Thank you very much for presenting, Ish. And